So, oh, stream started 3 minutes ago. Okay, cool. Let's try to do it better right now. I want to talk about architectural components today, and it's pretty important topic because many people already used architectural components in different applications. So, and it's pretty important to know how they implemented inside, because if we already understand how it's implemented inside, we can write better code. We can write code with better performance. We at Takeaway, as many other applications, use architecture components. And what I really found during communications with many people during interview or during discussions, that many people don't really understand how architecture components work inside. So I believe that it's really a good option to dive deeper and understand better how they work. So today I will talk about four architecture components for Lifecycle, LiveData, ViewModel, and Room. All these different components solve different problems. So I think this talk should have a lot of interesting information. So let's start with Lifecycle. And we always had problem with Lifecycle. So and very often you should write a lot of boilerplate code for your Lifecycle. Sometimes it just start fetching data from your database or maybe from the web service, sometimes from different data sources when you try to log into your application. So it means that at the beginning, when we start our screen, we should register many different components, and at the end we should unregister many components just to avoid memory leaks. So with new Lifecycle framework, we can do it better, and we can put a lifecycle of our Lifecycle owner into our inside our component. So inside our we can put lifecycle of our Lifecycle owner. So it means that in this case, inside logger, we put lifecycle of our Lifecycle owner. And in this case, first of all, we should add our observer. So inside our component, and whole our component will be an observer. So we need to add our logger to lifecycle of our activity. Later on, we can use annotations like on a lifecycle event, and inside these annotations, we can put as a parameter of this annotation, we can put a lifecycle event. And when we have destroy method, we also can unregister from our Lifecycle owner our observer. It means that we can handle all state and changing state of our Lifecycle owner inside our small component. And the whole Lifecycle framework has three pretty big parts. It's Lifecycle, Lifecycle owner, and Lifecycle observer. So today we will speak about Appcompat activity, a Lifecycle service, and a Fragment as about our Lifecycle owners. We have many other Lifecycle owners, and they based on a Fragment. So if you understand how Fragment work inside, you can understand how different Lifecycle owner work inside. The next part is our Lifecycle, and it's also super important part of our application. So let's start with this part. Inside Lifecycle, we have few methods. It's add observer, remove observer, and get current state. Inside get and remove observers, we can add our observer to Lifecycle owner, as we had in previous example. And if we combine event and state, both this event can be mapped and replaced with traditional approach with callbacks. However, in many cases, especially when you use Android X, use new approaches much more efficient. So I want to start with Appcompat activity as entry point of almost any Android applications right now. And Appcompat activity extends Fragment activity, and Fragment activity extends component activity. So when component activity is created, report fragment will be initialized. Report fragment dispatch all callbacks to all lifecycle events to our lifecycle registry, and our lifecycle registry can notify all our observers. A bit different situation we have with a fragment. So with fragment, we can use methods like perform start, stop, resume, etc. And inside this method will be called handle lifecycle event, and we will pass event, and it will communicate it with lifecycle registry, and lifecycle registry still can notify all our observers. The next big lifecycle owner is a service. So if we want to handle lifecycle of the service, we can use lifecycle service, which is built on top of the service. So inside the service, we have instance service lifecycle dispatcher, and this dispatcher send notification and this dispatcher dispatch lifecycle events to lifecycle registry, and still lifecycle registry can notify all objects, all observers. And one pretty interesting lifecycle owner, it's process lifecycle owner. It's like lifecycle of the whole process, and we can understand if our application is in background or in foreground. So if you want to use it, first of all, we need to add two dependencies. It's lifecycle extensions and lifecycle compiler. So during compilation, process lifecycle owner initializer will be created and added to Android manifest. And process lifecycle owner initializer has access to lifecycle dispatcher and process lifecycle owner. And both each component interact with report fragments, and you should remember that report fragments handle lifecycle of every activity or a fragment. So it means that inside report fragments we have a lot of information about every screen of our application, and later on it's sent to lifecycle registry. However, here a lifecycle registry will have a small delay, and this delay is needed for understanding that our activity really moved to the background or still in foreground. Because if we take a look at pretty simple application with two activity, and we want to move from activity 1 to activity 2, first in some moment of time our first activity will be in on stop state. It means that theoretically our activity moved to the background, or we need some time for open other activity. So for this reason, inside lifecycle registry we have 700 milliseconds delay, and together with this delay we can be sure that our activity is foreground or in a background. This is all about our lifecycle component. So if you have questions, please send them in a chat, and I will answer to questions after every section if we will have answers. And let's wait for a few seconds, and if we don't have more questions, I will continue. So I see that right now we don't have questions. So let's move to the LiveData. LiveData is observable data holder. It means that we can store some data inside LiveData object. So when we want to get any data from LiveData object, we can use three methods. It's observe method, observe forever, and get value. So let's start with observe method. So observe method is really lifecycle aware method. because we put a lifecycle as one of parameter to observe method. The next part is observe forever method, and observe forever method is not lifecycle aware because we don't put any lifecycle, and I recommend avoid this method when it's possible, because this method can generate a lot of problems for you, because you should remember to unsubscribe from this method. And get value method just return data which you have inside your LiveData object. And right now I want to move to observe and lifecycle aware method, with our observe method with our lifecycle owner and our lifecycle observer. And the first method which we have inside it is we check that this method called from the main thread. So if it's called from the main thread, the next step we should check that lifecycle owner is not destroyed. And when our lifecycle owner is not destroyed, we check that our observer is unique in context of owner. It means that we cannot register the same observer with different lifecycle owners. If you want to observe LiveData object with different lifecycle owners, you can register new observer for every lifecycle owner, and in this way it will work pretty well. Later on, it will be registered. Our observer will be added to observer list of our lifecycle owner with a lifecycle bound observer. So at the end, when our lifecycle owner, before destroying our lifecycle owner, we will remove our lifecycle we will remove observer from our lifecycle owner observer list. And the pretty important part is set value and post value methods, because this method allows us to set any data inside our LiveData object. And let's start with set value method. So inside set value method, the first method is we check that we are on the main thread. After it, we increment data version, and when data version is incremented, all observers will receive the latest data. So for this reason, we need to increment data version for every observer, because one observer can be added before another one. So at the end, we want to synchronize on observers and send similar data to all observers. The next method is post value method. So with post value method, the first thing which we do is we put our value from the worker thread to the main thread, and after it we check that we are on the main thread, increment version, and notify all observers. So in this case, super important to understand that LiveData was built for interaction with our UI, because we can change our UI only from the main thread. If you will use your LiveData object inside your data layer, it will be super inefficient, because let's imagine you get some data from your web service, and from web service you will use post method value just to set data to LiveData object, and it will be put to the main thread. And it means that if you want to do some transformation, very often all this transformation will be done on the main thread, which of course is super inefficient, especially if you have pretty complicated transformations. And the last method which helps us to get a value from LiveData object is get value method. And unfortunately, I saw many examples when people expect that get value method to return a nullable type. And it's pretty interesting, because even Android Studio shows that it's nullable type. However, if you check internal implementation, you can see that it can return data from LiveData object, or it can just return null. And let's move to the ViewModel. So all of ViewModel was created for getting sorry, ViewModel was created for handling configuration changes. So what is configuration changes? First of all, it's when we rotate device. But in addition to it, when system language of your device is changed, your application also should be updated. So for it we can use ViewModel, and I want to start with pretty different approaches which we had during last 10 years of Android development. And I think every developer who works with Android more than a few years, as minimum once in their life, try to use or try to explore config changes method, config changes orientation parameters, which can be added to Android manifest. So these parameters blocks the framework for configuration changes. However, you can do it manually. But in this case, you should remember that if you try to do it manually, you should rewrite pretty big part of the framework. As example, you lose possibility to have different load automatically different layouts for portrait and landscape, different translations for different parameters. So if you really want to use it, you should rewrite pretty big part of the framework, and it can be super complicated to write it without any issues. So the next approach, which was used a lot, is using onRetain non-configuration instance and getLast non-configuration instance. So for activity, we have an agreement that onRetain non-configuration instance and onRetain custom non-configuration instance will be executed between onStop and onDestroy. So before destroying activity, we can cache some data or even whole activity object. And when our activity will be recreated, we can get this object using a getLast non-configuration instance. So it means that we can cache some data before destroying activity and cache this data after recreating of the activity. So it means that you can do really in pretty simple way. You can cache some data, and it was used by many people. And sometimes people cache previous activity object. So in this case, after recreating, you will have access to current activity object and to the previous activity object, and you can get already calculated data. However, to make it workable, you also should play a lot with onSave instance state method and onRestore instance state. So it also required to write a lot of boilerplate code. The next approach appears together with fragments. So usually when fragment attached to the activity, and your activity will be recreated, your fragment will be recreated too. However, you can use retain instance parameter, and together with this parameter, fragment will survive configuration changes. So if you will do it, you can calculate data or put already calculated data inside your retain fragments, and after it in your retain fragment, you can get this data after configuration changes and after your activity will be recreated. However, you should write a lot of boilerplate code. First of all, we should not attach new fragment every time. First of all, we should check if fragment already exists, and if it's already exists, just add a new fragment. If it's new, if this fragment is new, we should create an instance of a fragment. Later on, we need to create a communication protocol between our retain fragment and our activity or traditional fragment. And as you can imagine, if you have many retained fragments, you should have many such contracts. And of course, maintain them is not the simplest task. The next approach is pretty modern approach, which right now used by many developers. It's our ViewModel. So if we want to create ViewModel, we can create a class and extend this class with ViewModel or Android ViewModel if we need an Android context. And later on it will be, we can get our instance of our ViewModel using ViewModel provider or ViewModel providers, which right now is deprecated. So in practice, the really good way to get it is use ViewModel provider. So, and here we should take a look how it works inside, and we should take a look at two different scenarios. The first scenario is that we open our screen for the first time, and our ViewModel wasn't created yet. In this case, it will be created by Android ViewModel factory, and in this case can be created classes which extends ViewModel or Android ViewModel. When our ViewModel instance will be created, it will be cached inside ViewModel store. And later on, this object will be returned as our ViewModel. However, if our ViewModel already was created, we will get this object from the ViewModel store and just return to the client. And if we take a look at our component activity, which handle a lot of lifecycle changes, inside this activity, we can get our ViewModel store from getLastNonConfiguration instance, which is pretty similar to our pretty old approach for configuration changes. So let's take a look at onRetaiNonConfiguration instance from the component activity. And here we can see that before destroying activity, we cache our ViewModel store. And when our activity recreated, we get our ViewModel store from getLastNonConfiguration instance. It means that we use pretty old approach. Of course, this approach was polished and improved, and we can see that we have no magic inside our ViewModel. We have pretty old approach, and right now it's working for the ViewModel. However, I explored how it works with ViewModel providers, and this implementation was around 1.5 years ago. And inside ViewModel, when we use ViewModel providers, it means that implementation of it was based on retained fragments. So as you can see, we have for implementation ViewModel provider and ViewModel providers was used different approaches, but all these approaches was based on previous implementation. So we can be sure that inside creating ViewModel we have no magic. Right now we can understand better how it works inside, and I believe for people who started some time ago using getLastNonConfiguration instance and onRetaiNonConfiguration instance, it also can be something new, because right now it's not super popular method, but it's always good to know that we have possibility to restore state using such methods. And right now I want to move to the room library. So room library, it's super important library, and very important to understand that it's library, it's not a framework, because sometimes when I read some articles I see that they mentioned room database. In reality we have no room database, because under the hood room use SQLite database. So it's pretty old and pretty traditional way to work with database. And let's take a look how it's implemented inside. So what we have inside? Inside we have SQLite, and SQLite installed on every device. So here you have different IP versions. They was mostly checked at emulators and Pixel devices. So it's what Google sends to different vendors. So here you can see that version of SQLite is changing from version to version. However, we should remember that every vendor can use older or newer version of SQLite. And let's imagine that you can have you have two devices from different vendors with the same version of Android installed, and sometimes you can have different version of SQLite. And if you check change log of SQLite, you can see that a lot of stuff is improved and fixed. So theoretically, you can have a situation when you interact with database, it can work a bit differently on different devices, and on an older version it can have an issue. So for this reason, using only a Roboelectric framework for testing interaction with database, it's not a good idea, because theoretically you can have an issue, and together with this issue your application can work a bit differently on different devices. But if you use instrumentation tests, you can run your test on different devices and it always will work well. So when we try to create our database, first of all we need to create a table, and for creating table we need to use entity annotation, and every entity should have its minimum one primary key. The next part that we need to create data access object. It means that we should generate interface with DAO annotation, and inside this interface we can use annotations like query, insert, update, delete, etc. And the last part is to create our database class, which should extend room database and which should have database annotation. As parameter of these annotations, we should put all entities and version which is needed for migration. And all magic for room we have during compilation, because during compilation few more classes will be generated. So one class for every data access object will be created, and this class will be created with _impl annotation. And I propose to take a look at most popular approaches and most popular operations which we usually do with database. So we can insert the data, and inside our interface with DAO annotation we had method insert employee, and I propose to start with this method. So in this method we can see that everything will be inserted in one transaction, and in this method we can see that we use insertion adapter, and this insertion adapter override two methods. It's create query and bind. So bind method map our entity object to the SQLite statement. So when it will be mapped, and we need to use it in other method. So in other method it's create query. So inside create query we have simple SQL query but with question marks. So this adapter will merge our SQLite statement with our SQL query, and all value from our entity will be added to our SQL query. Pretty similar situation we have with updating data in database. So, and here inside where section of our query we have ID. In practice, in this section will always be primary key of our database. So the next and the most fun method is delete method, because as you can see in SQL query, inside delete method we check only our primary key. So if you imagine that inside your database you have one object and you have completely different object, and you put it into delete method but with similar ID, this the different object with similar ID can be removed from your database. From one side it's bad because it wouldn't be complete, it can be almost completely different object, but from optimization perspective it's pretty well. However, yeah, you can just create any object but with proper ID and it will work well. And the last part is getting data from database. For it we use query annotations. So in this case, from such methods we return flow of list of employee, And let's start from the very beginning. And when we get query to the database, we return a cursor. I think it's familiar for everyone who work with pretty old SQLite Open Helper. And right now we have a cursor, and the next step is to map data from this cursor to the list of employee. And when it's done, the last part is wrapped with create a flow method, which is under the hood use Kotlin channels. So as you can see, we have a lot of code which 5, probably 7 years ago was created manually, right now just generated, and we should create just a few classes, few interfaces, and a lot of work will be already done. And of course it's great, and it's super good simplification for us because we shouldn't write a lot of boilerplate code. And the last part which we have for our database, it's creating our database object. So during compilation, one more generated class will be created, and inside this class, as you can see, this class extends our abstract class and implement many methods. As example methods for our data, all our data access objects. We also have method for clear all database, and inside create open helper class, we have a lot of stuff for creating tables, do migrations, creating connection to our database, and our invalidation tracker check that our database was created properly, or tables are correct, and one more additional table will be created. Of course, this table it's pretty hidden, but this table is needed for room migrations. So I really want to encourage you after this talk, explore your everyday tools, because we all use many tools, many frameworks for every day, and all our work is connecting with different frameworks and libraries. And I really encourage you to explore more such libraries. First of all, it makes you better engineer. You can write a more performant code because you can really understand what you have inside. And in addition to it, if you explore different frameworks, you can apply approaches which was used for building this framework into your code, and it means that your code can be more generic and can be just better. And of course you will have better performance, because when you understand that LiveData is good for UI but not good for data layers, if you use this approach, you can replace it. If you think about this approach, you can avoid and switch to better solution, which has better performance for multi-threading, and it also will have better usability. So I really encourage you to check more tools, and if you have any questions, please send them in a chat, and I will answer to all questions. If you have any feedback, please also provide this feedback to me in a chat, or maybe in chat, or maybe in the comments. So yes, we have no questions on chat, so let's check question on Mentimeter. So the first question is, can a lifecycle owner be something other than a fragment or activity? Yes, one of such lifecycle owner is its service, and you can create your own lifecycle owner with custom behavior. So it means that if you need, for some specific cases, For some specific cases, of course, you can create it. So let's move to the next question. Does it matter for us if the view model is using retained fragment or not? Should we worry about it? We shouldn't worry about it, because this frameworks was tested very well, and right now many people use this approach. It was pretty important some time ago, when people just start rewrite a lot of application, a lot of layers in application, and switch from retained fragments to view model. And it wasn't needed if your approach worked well, because under the hood it worked in pretty similar way. So that's why it's really good to understand how it works inside, because if you know how it works inside, you can save some time, or you can apply similar approaches to your solutions. The next question, how reliable is Room? When we often change our database model, do issues with compilation occur, like need to end invalidation check and restart often? I never had such issue, because when we change our database, we work with migration, and Room has pretty good mechanism for migration. And if we take a look our internal changes for migration, it also really depends on the migration operation, because when we add one type of migration, we want to add just one column. So in this case, this column just will be added. But if we want change, as example, type of one of the column, first of all, completely new table will be created. All data will be moved from the old table to the new one, and after it, all table will be removed, and the new table will be renamed to the old version. So as you can see here, we also have different migration type, and different job is done for migrations. And I never had issue with invalidating cache and restart for database, or even for Android Studio. For me, it always work well. However, maybe for big and complex project, it can have some issue. First of all, because of using RAM for Android Studio, because Android Studio use a lot of RAM. So the next question: did you encounter any issue related to queries generated by Room? Do you know how does it compare using other databases of Android, for example, in terms of performance? So in practice, about other databases, performance of SQLite database is pretty good for Android. I know that some time ago, Room database had issue with like operation, especially for the string types. So performance of SQLite database is pretty good. However, it really depends what you want to store in your database, because usually mobile applications store pretty small amount of data, and of course it's no issue with performance. I know that some companies store a lot of data, like map, which is used as example for can be used for navigation. So in this case, database will be bigger, and of course use Android approach with Room or SQLite Open Helper can be pretty slow. And in this, if you really need performance, you can add a GNI and interact with your SQLite database using C++ layer, and it will be a bit faster. But it really depends if you need it, because if you store only user data or data from your web service, you don't need it. What is the limit of complexity the Room can handle? I never had issue with something with the Room. it has some limitations, because Room under the Room has really cool feature that all your queries will be checked during compilation. But when you have super big query, it should be written in one line. So if your query is super long and you try to split it into few lines, it will be understood as usual string, and it has problem with checking your query during compilation, and unfortunately sometimes it's an issue. Can I use SQLite cipher with Room or any other form of encryption my database? Some time ago, I saw that it was announced that SQLite cipher will support Room database, but I cannot answer for sure if it's really support this combination. So right now Google working on Jetpack security. So, and I believe that security in future can be also combined with Room without any issues. LiveData was not a good solution for single events. By single, I mean that were sent only once. Was this addressed by Google? It wasn't addressed, as I know, it wasn't addressed by Google. However, you can easily find snippet of code which Google recommend to use for single events. And yeah, this was a problem, that if you want to send something only once, you should don't use LiveData. You should usually, if you find the snippet, it's probably called single LiveData, and you should write additional code. So it means that this library, it wasn't completely finished, and it is good for UI. It's good when you want to send updates to the UI, but some cases wasn't handled from my perspective. Did Google introduce a framework for writing custom lifecycle aware components similar to LiveData? You can create lifecycle. You can create lifecycle aware components, but I don't know if it's really needed, because many popular you can do something similar, and you can handle it pretty easy, as example with RX or with a Kotlin flow. So I don't really know why it's needed. Of course, I believe it should be possible to create this example for observable, make observable lifecycle aware. However, in RX you have other really good tools, and you can also create. You can create your own component and make it as we did with Logger, and handle lifecycle inside such object. So if you on it based some type like LiveData, it also will work fine and will handle lifecycle state. Yes. Have you encountered bugs in Android architecture components that you diagnose by looking at the source code of the library? No, because in my case, what I usually do is, when something is not working, and I go deeper to the source code and check how it works inside. And in some cases, you start understand how it works inside, and that this component was created for different purposes. Because unfortunately, sometimes documentation is not updated, as it usually happened in many projects. But exploring tools provide to you, give you many benefits. You can apply such techniques to your code and make it better, as example. So we don't have any question, And I want to say thank you first of all for patience because of stream issue, and I hope it was helpful. I hope it was interesting and you learned something new, and you will explore more and be better developers and better engineers. Thank you for participating. Thank you for participating in the event. If you have comments and suggestions, please add them below the video. And yes, thank you.